Hello, my name is Garry Jackson, and I'm in Fundamentals of Physics, September 2010, section number 1. Today, in this podcast, we will be looking at the conservation of momentum and energy. Well, one might ask, what is momentum? Well, momentum is simply defined as inertia in motion. And it can be represented by the equation P equals m times v, where P represents momentum, m represents the mass, and v represents the velocity. Now let's talk about the conservation of momentum. In every case, the momentum of a system cannot change unless it is acted on by an external force. A system will have the same momentum both before and after any interaction occurs. When the momentum does not change, we say that it is conserved. In the absence of an external force, the momentum of a system remains unchanged. This is what is known as the law of the conservation of momentum, and is represented by the equation that total momentum before is equal to the total momentum after. Our lesson today will be looking at an idea known as Newton's cradle, which was first devised nearly 400 years ago by this French physicist by the name of Abbé Marriott. So today in our demonstration, the momentum and energy must be maintained in this system, which is represented here by these 4 quarters, 5 quarters. We're using just a regular brown table, storybook ending to provide the balance. The main focus is here amongst these 4 quarters actually, because this is the quarter we'll be using to show the conservation of momentum within the system of these 4 quarters here. Once we send this quarter in motion with a certain velocity, the quarters represented here must move at the same velocity that was sent in with the initial motion. Plain and simple, if one quarter hits the group, which is represented here, one should be sent in motion to determine how long. Let's test our theory. This is going to be our test quarter here. Let's watch what happens with this quarter. But once the impact came here, because of the law of the conservation of momentum, this quarter received the same impact as this quarter right here, leaving the initial unit that was there. See that one more time. 4 quarters here. This is our testing quarter. Same thing. This should also remain true if we use 2 quarters. So we see we have 3 quarters remaining. 2 quarters were sent off, thus solidifying the concept. That concludes our demonstration for today on momentum and the laws of conservation of momentum and energy. Hope that you all learned something today. I definitely have, and we will see you next time.